Hi everyone, so in this video we'll be looking at the new functional group called the esters. So the esters are what we call the artificial sweeteners. So they are, as long as you actually have an artificial taste or artificial flavoring, most of the time there's an ester in it. So an ester is actually one of the reactions of carboxylic acid. Previously, we talked about carboxylic acids acting as acids, and now we're talking about carboxylic acids reacting in an organic reaction. Now, the esters are actually very unreactive stable because they contain the ester bond or the ester link, and the ester bond or ester link look something like that. Okay, so this is the ester bond or the ester link. You need to know this. Okay, and esters are actually formed by this reaction called esterification, and it's a reaction between the carboxylic acid and the alcohol, and this reaction is a condensation reaction. If it's a condensation reaction, means that water must be produced. So this is how the reaction looks like. Okay, so the alcohol reacts with the carboxylic acid with some concentrated sulfuric acid catalyst. Right, you form the ester and water. So let me show it to you. So we know that anything that reacts with ethanoic acid will form a ethanoate. Okay, so the same thing for ester. Because of the ethanoic, they will form the ethanoate. And then over here, we have the methanol. We take the first few letters and we call this methyl ethanoate, and this is actually a simple molecule. Later I'll draw it and you will know. So it's actually very different from what we have written up here. Over here, the acid reactions, it's actually ionic salts. But over here, when I form my methyl ethanoate, it's actually a simple molecule. Don't forget, water is being produced. So how does it look like? So let me just draw it for you. So I got my methanol, nicely over here, one carbon. I have my ethanoic acid. I like to draw the functional groups facing each other so I can show it to you very clearly. So my ethanoic acid, my methanol, and you must remember, my water must come out. So that means, right, H2O must come out. So the H and the O, okay? So what happens here, let me do some technology magic. I have the H, can I copy this? Yep, paste, perfect. I have this part, right? And then on the other side, I have this part here, right? And I'll copy this, and I'll paste it here, right? And then after that, I just join it together like that, okay? And then you see, it forms the ester link. Okay, and what we must know is that this side comes from the acid. So the acid, I'll color it green. So this is the acid side, right? This is the acid side, right? And then let's color it yellow. This is from the alcohol side. So the name also the same. The name, alcohol, and then acid. So the acid is always the 8, right? And then the alcohol side is the something tau, YL. So let's try for the next one. So we got ethanol and then methanoic acid. So ethanol, methanoic acid, anything that's with methanoic acid will form something that is methanoate. Okay, so this name comes from the acid, the methanoic become the methanoate, right? And then the ethanol, the ETH become the ETHYL, ethyl methanoate plus water. So that's the name of the ester. So let's draw it out. I have 2 carbons. I have 2 carbons plus methanoic acid is 1 carbon. Right? I remember that I removed the H and O, okay, because I want to create the ester bond. So the water gets removed. So then I have one side that's like this, right, with the O, and then on the other side it joins the C double bond O and then H. Remembering that this side comes from the alcohol, right, and then this side comes from the acid. Okay, so now we know how to draw the reaction. We need to start from the ester and then tell me what's the product or what's the name. Okay, so let's look at some esters. So the first ester that we have over here, let's look at the name. So what you need to do is to first find the ester bond. So I have the ester bond over here. Now, you find for the C double bond O. This means that this side here must be the acid. Okay, you find for the C double bond O, right? Because that is where the acid will come. And then I have 1 and then I have 2. So that means it's a 2. So 2 is my expensive product back, ETH. And then since it comes from the acid that contains 2, so ETH ethanoate. Ethanoate. And then on the other side comes from the alcohol, so it ends with a YL. So this one 1, 2, 3, 4. So my expensive product back, B. So it's BUT, butyl ethanoate. So butyl ethanoate is made out of an acid that contains 2 carbons. So acid that contains 2 carbons, which is this, as well as an alcohol that contains 4. Okay, so 1, 2, 3, 4. Let me draw all the bonds first. Okay, contains 4. So it's a reaction between ethanoic acid as well as butanol. Okay, let's do the next one. So we got another ester. So again, what I told you, look for the C double bond O. Right, I found the ester link and I find the C double bond O. That means that this whole part at the C double bond O, including the C double bond O, must come from the acid. Okay, and then we count number of carbons. Remember to count C double bond O. 1, 2, 3, 4. So this is a noate, right? 4 is my expensive product back, but. B-U-T, noate, butanoate. On this side, 1, 2, so ETHYL, ethyl butanoate. Ethyl butanoate comes from ethanol plus butanoic acid. Okay, you can go and draw it up yourself. Alright, now let's look at 2 more examples. Over here, we have another ester. Find the ester link. Step 1. Step 2, find the C double bond O. And then color this side, C double bond O. Remembering that this side is the acid side. Okay, the acid side has 1 carbon, 2 carbon. So it's my expensive ETH. And it's from the acid side, so it's a ethanoate. On the alcohol side, which is this one, 1, 2, 3. So this is prop and propyl ethanoate. So propyl ethanoate is from ethanoic acid. That's why you got the ethanoate. And then you form from propanol. That's how you got the propyl. Okay? Last one. Step 1, find the link. Step 2, find the C double bond O. And then remember that the C double bond O, this side is the acid. Step 3, count the number of carbons, including the C double bond O carbon. 2 carbons, so this is a ETH. And then, because it's on the acid side, so it's ethanoate. Count the alcohol side, we got 1. So this is METH, methyl ethanoate. Methyl ethanoate is made out of methanol, the 1 carbon alcohol, and a 2 carbon ethanoic acid. So do practice to draw, do practice to name, and then practice, and then you'll get a hang of it. Alright, all the best. Bye.